This videotape contains an introduction for the malfunction phenomenon, a setup of the service guideline, a service work, and a final test. Malfunction phenomena introduction. The related vehicle model is the Sorento 2.5 diesel with regards to a typical malfunction occurring at roughly 55,000 kilometers. Now, let's see the malfunction phenomenon on the screen. When driving, the vehicle's engine stops with the engine warning lamp on. At this time, you can see that the engine's RPM rapidly decreases and that the engine warning lamp is on. The high scan then indicates a 1181 fuel pressure monitoring malfunction, and the related cause code of C010 fuel pressure high and engine RPM high is shown. At this time, the measured value of the fuel pressure sensor illustrates the difference between the actual value and the target value for fuel pressure. I will now explain malfunction code P1181. In the P1181, there are several detailed codes. Among these, the most common are C006 and C010. This case concerns the C010, a deficiency to the proper rail pressure according to the RPM. In order for this condition to occur, as shown in the previous caption, the 300 bar at 800 RPM refers to the detail fault code that will be shown when the fuel pressure actual value has a difference of 300 bar and equal or more to the target value. Additionally, in the condition of 250 bar at 2000 RPM, when the actual value of fuel pressure has more than 250 bar differences from the target value, the detail fault code will be output. The fail mode, when this fault code is output, controls the fuel amount to equal 0%. Therefore, the engine will shut off during driving as shown in the phenomenon. Under the release condition, this control will be released as soon as the signal is normally input. Setting up the service guideline. Next, I will explain how to check the guideline using the caption. As the fault codes mentioned above are output, first check the fault on the fuel filter. Second, check the high pressure pump as well as the MPROP, which is a kind of fuel control valve in the high pressure pump. Third, check the fault on the common rail and the RPS, the fuel pressure sensor, installed in the common rail. And last, check the overall condition of the injector. For example, the injector's air tightness, among others. Service work. Check the fault on the fuel filter. As shown on the screen, the filter is placed under the intake manifold. Here, the most important thing is checking the fuel flow amount at the inlet and outlet port. As shown in the picture below, it is recommended to use a transparent tube. You can see that the fuel is injected from the fuel tank to the common rail pipe. This picture is for normal operations. As such, the fuel should be supplied to the outlet port in the filter so that the engine will work normally. In addition, you should check the inside of the fuel filter. To do so, check any tearing of the O-ring or any other defect that may result from air tightness. Furthermore, confirm if the rubber seal ring is functioning normally. You also should inspect the fault on the fuel in the filter. At this time, please check to see whether or not any foreign materials, including metallic powders or moisture, are mixed. To do so, we recommend checking the diesel fuel in a vessel using a magnet as shown on the screen. In the situation shown on the screen, there are no foreign materials. However, as shown in the smaller scene on the side, if any metallic materials are found, the filter has defects. Check the fault on the high-pressure pump. As you can see on your screen, the high-pressure pump is placed in the middle of the engine's front. To check the high-pressure pump, first check the MPROP, the fuel control valve. As shown in the picture, first check the wiring status. Here, there are two wires between the MPROP and the ECU for control in duty value. Under normal circumstances, on this side the resistance should be 994 ohms and almost infinite ohms. And on the opposite side, the wire should have an infinite value of ohm. As the MPROP is also a solenoid valve, the internal resistance is very important. As stated in the caption, the regulated value is 2.9 to 3.2 ohms. Now, let's check this vehicle's resistance. As you can see, the regulated value shows about 3.2 ohms. So the MPROP is functioning normally. Now that we have determined that the MPROP is normal, the high-pressure pump should be examined using the closed system method for checking performance. During this time, all terminals of the MPROP and the injector should be removed, and then the engine should be cranked. Lastly, checking the rail pressure value of the high scan. For the above vehicle, the rail pressure is about 1,000 bar or more. Thus, in this situation, the discharging performance of the high-pressure pump is within normal range. Check the fault on the common rail. Next, you should check the air tightness in the common rail. In the circumstance shown on the screen, we suggest using a vacuum pump. For a vacuum pump, the number 1 high-pressure supplying pipe can be used for the adapter. Now, let's check the results after pumping. In this example of a normal vacuum value, the vacuum state of the common rail is excellent. However, in a malfunction state, the vacuum is first measured and then the vacuum state erodes slowly, as shown in the right side picture. In this case, the air tightness in some portion of the common rail is defective. Now, after conducting a test of air tightness, you should check the rail pressure sensor to see if it is measuring properly and normally. At the cranking, the rail pressure should increase rapidly and then decrease slowly. At the lower part of the diagram, you can see an abnormal waveform illustrating an abrupt decrease in pressure value. This signifies a defect in the rail pressure sensor or a failure in the air tightness of the common rail. Check the fault on the injector. You should perform both the injector back leak test and the high scan test. First, let me explain the back leak test for you. After the engine is cranked, the leak amount will be back to each tank. Let's see the results as shown on your screen. From the results of the back leak test, the amount from the number 3 injector is higher or lower than the other injector. With this information, you would assume that the number 3 injector is defective. To verify, you should check the results from the high scan test. For the high scan test, you should check the idle speed comparing test mode in the compressed pressure test mode. As you can see on your screen, the idle speed comparison test mode is being operated. Let's find out the results. As in the back leak test, the number 3 cylinder RPM is reduced. By conducting these two tests, you can assume that the number 3 injector is defective. Now the replacement of the injector is complete. You should also check the state of the overall engine again after this. As you can see on the screen, the RPM of each cylinder and the back leak has returned to its normal state. The cylinder now functions normally. Final test. As you can see, the vehicle is running normally. And last, let's recheck the malfunction code. The fault code shows a normal state. Has been and is currently doing its best to promote effective